Hey there everyone! Today we're going to be talking about properties of logs. And so I've got this chart here set up for us to fill in some information for the properties of logs. Um, you can either screenshot this while we're taking notes or write this down, that way you have a paper copy for yourself. But just like exponents have special rules when it comes to certain operations, so do logs. And I compare these to exponents because remember, we can transform a log and put it in exponential form, or we can put an exponent in logarithmic form. Alright, so you can go back and forth between exponential and logarithmic. So just like exponential functions and exponential expressions have special rules, so do logs. The first rule that we're going to look at is called the zero power rule. Alright, the zero power rule means that anytime we have a log with an argument of 1, that means it's going to be equal to 0. So here's that rule in symbols. Let's say I've got log with a base of, I'll just say b for base. And we're going to say the argument is 1. Remember, the argument is right there up above your base of the log. Anytime, it doesn't matter what your base is, if you have a log and your argument, this number right here, is 1, it's always going to be equal to 0. Alright? So if we had an example like log base 7 of 1, since our argument is 1, that means this is equal to 0. And here's the reason. Remember when we can go back and forth between logs and exponents? If I turned this log into an exponent form, 7 is my base, and then right here, this number on the outside is my power. So 7 to the 0 power is equal to 1, my argument. Alright? So anytime your argument is 1, that means you have a power of 0. Alright? Which is why this is called the zero power rule. Our next rule is the same base rule. Same base rule. Alright, and what that rule says is any log with the same base and argument is going to be equal to 1. Alright, so here's an example. Our rule in symbols, we have a log, and let's just say we have a base of b, some number b, and let's say our argument is also a b. If both our base and our argument are the exact same, then that means our log is always going to be equal to 1. Alright, so for an example, let's say if we have log base 4 and we have a 4 right here, that's going to be equal to 1. And the reason, again, is if we were to put this into exponential form, 4 is our base, 1 is our power. 4 to the first power is just 4. Alright? So whenever your base and your argument are exactly the same, your answer, your power, is always going to be 1. That's the same base rule. Alright? Now we're going to be getting into some rules that we're going to see that are a little different, but still work. So Our next is the product rule. The product rule. And we use these rules to be able to combine or simplify logs or exponents. So we need to know these rules in order to help us to get, our end goal is to be able to solve logs and exponents, alright? So, the product rule, remember product is the answer to a multiplication problem. So, anytime we see a multiplication expression inside an argument, that means we can change that multiplication, we can split the logs and change that multiplication to addition. Alright, here's an example of what that might look like. So, let's say we have log with a base of b, and we have, like, I'm just going to use variables for right now when we're in symbols, m, n. Alright, log base b, m, n. Remember, if we've got two variables that are right next to each other and there's no symbol in between them, that invisible symbol is a multiplication sign, right? So we've got multiplication happening here in our argument, log base b of m times n. So what we can do is split this into an addition problem. So that means I can just split it and say log base b of m and log base b of n, and change that multiplication sign to an addition sign. So you'll see my log and the base didn't change. My arguments still stayed the same, but I separated them using an addition sign. Alright? So if we wanted to take a look at an example like this, if we had log base 3 of 6x, using the product rule, this is saying 6 times x. Okay, so I can split this into log base 3 of 6 plus log base 3 of x. Alright? Our next one is, I'm going to find a different color here, the quotient rule. Alright, so in the quotient rule, this is the same idea, but any division that we see inside an argument, we can now split into a subtraction of the logs. Alright, so the way we're going to see that here is if we have in symbols log, and again I'll just use base b, and I'll use the same letters m and n. If I've got m over n, like this. Okay, so this fraction sign, remember a fraction is the same thing as a division problem, alright? So we see division in our argument, so we can split our argument into two logs using subtraction. So this is going to be changed to log base b of my numerator is m, and then log base b of my denominator n, and I'm going to change that division to subtraction. So our example, if we have log base 5 of 10 over x, we can split that into log base 5 of 10 minus log base 5 of x. Alright? And we can go back and forth between these. If I see subtraction like this, where my bases are the same, that means I can put it back together and make it smaller rather than expanding it out into the long form like this. All right, the last rule that we're going to take a look at, what color do I want to use? Decisions. All right, the last one is the power to a power rule. Power to a power rule. All right, and what this rule says is any exponent that we have in an argument can be moved in front of the log. All right, here's what that looks like. This is what we're talking about. All right, so let's say we have log base b, and let's say we have it, in our argument we have x to the m power. All right, so we have this m up in our exponent, up in the power. Well, since logs can be changed to exponents, to make it easier on us, we don't want an exponent inside a potentially exponential expression. So we're going to move that exponent and we're going to put it in front of the log. So the m is going to go in front, and then we can just write the rest of our log base b of x. Alright, and that way we can much easier change this log into an exponential expression. Alright, so our example is, let's say we've got log base 2 x to the 4th. We can change this to put that 4 out front and then write our log base 2 of x. Alright, so there's our rules. If you need to, screenshot this or freeze it so that you can write down anything that you might have missed. We're going to take a look at a couple examples similar to the homework, and then you guys should be good to go. Alright, so I'm going to move this, and we're going to take a look at some examples. Alright, the goal is to be able to use multiple of these rules at one time on the same problem, because a lot of times that'll happen. There are two ways to use properties of logs. We can expand, like what we did in our examples here. We expanded and made them longer. Or we can condense, meaning we're going to work it backwards, and if it's in the long form, we're going to put it in the short form, and that's condensing. Alright, so first we're going to start with expanding expressions. Expanding expressions. Alright, so we're going to do a couple examples here. I'm going to start with 1 and 2 and then see how much space I take up. Alright, so let's say we have log base 7 36x squared. Alright, so we want to expand this. Alright, when we expand, we want to look to see if we have any rules that we can apply here. So, what do you see? Alright, we see a power, and we see multiplication, 36 times x squared. So what I'm going to do, that is the product rule. And then this right here, we're going to be using the power to a power. power to power. So, like I said, we want to be able to use multiple rules at one time. The product rule means we're going to split this and use addition. So that means I've got log base 7 of 36 plus, because that product rule means we can change that to addition, we've got log base 7 of x squared. What can we do when we've got a power? We bring it to the front of that log. So I'm going to put that squared in front, and there we go. We have expanded our expression. Alright? Using multiple rules at one time. Let's take a look at another example. Let's say we've got log base 2 of 2 over 5. Alright, we want to expand this. Now, what do you guys see here? Division. Very good. So, we are going to use the quotient rule. Whoop, I just spelled quotient wrong. Quotient rule. So if I use the quotient rule here, that means we can split this into subtractions. We've got log base 2 of 2 minus log base 2 of 5. So you may think we're done, but do you guys see any other rule that we could use here? Hey, yeah, that's exactly right. That's exactly right. We have the same base. This is the same base rule because our base and our argument are exactly the same. And that same base rule means that this log base 2 of 2 is really just the number 1. So our final answer here would be 1 minus log base 2 of 5. And there's our final answer. We have expanded this as much as we could. Alright, we're going to take a look at 2 more examples of expanding, and then we'll take a look at condensing. Alright, so we do example 3, example 4. For example 3, we're going to have the natural log. Alright, so anytime you see ln, that's still a log. It's just a natural log because we're using the natural number e. Alright, but that's still a log, so this is natural log. We're going to have 6x squared over y to the 4th. Alright, so we've got several things happening here, right? If it helps, if you guys don't want to multitask and use multiple rules all at one time, just take it one piece at a time. Alright, the biggest thing that sticks out here the most is right here. We've got our quotient rule. So if it helps, go ahead and just take it one step at a time. So if we use the quotient rule, that means we're going to have, I'm going to keep this in gray for right now, we're going to have natural log of 6x squared, and then that quotient rule means we can change that division to a minus sign, and then have natural log of y to the 4th. Alright? Now, what do you guys see next? Okay, we see some powers, and we also see some product happening here. So this is the product rule. And then we also see the power to power rule. Power to power. Okay, now what I want you guys to be careful of, in this case, I don't want to do my power to power rule first, because is this squared applying to the 6 or the x? That squared is not applying to the 6 because there's not a parentheses around the 6 with that 2 on the outside. That squared is only going to the x. So in order to make sure I put that 2 in the right place, I need to split. I need to use the product rule first and then use my power rule to move that 2. So that is going to look like this. I'm going to split it first. So we're going to have the natural log of 6 plus that 2 was going to the x. So that 2 goes in front of our natural log of x. Alright? Then we are going to have our minus sign. So minus, and then move that 4 to the front of this natural log, minus 4 natural log of y. And there is our final expanded expression. Okay, and then for number 4, if we have the natural log of 15x Alright, what do you guys see here? That's right. There's only one rule that we're going to use here, and that is the product rule. So all we need to do is split it with an addition sign. So we're going to have our natural log of 15 plus our natural log of x. Okay, that is expanding expressions. We're going to take a quick look at condensing expressions, and then you guys should be good to go. Condensing expressions. Alright. So, with condensing expressions, remember, we're going to use the rules to go backwards and put these back together. Alright, so with example 1, let's see here, we're going to have 2 log x plus log 11. Alright, so you guys might notice here that there is no number in the base. Alright, and this is just like if you have something to the first power, you typically don't put a number 1 up in the power, or if you only have 1x, you just write an x rather than 1x. For logs, if there's no number down here in the base, that means you have a base of 10, because that's typically how we count. We count in tens. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we start back over with a 1, but now it's 11, 12, 13, 14, 15, and so on. Alright, so log with no base is really log base 10. But anyways, we're going to condense this, so put this all back together. And so what do we see here? Well, right here, this is our power to a power. So this 2 is going to come back up here in the exponent. And then right here, that plus sign means what? Yeah, the product rule. Okay, so that means we can rewrite this as moving that 2 back up to the power. So this is going to be log x squared and then times 11. So you can put that dot there for multiplication if you want. Now, I'm really quickly going to rewrite this because normally, if I have x squared times 11, how would we answer that? 11x squared, right? So, I'm just going to rewrite this with that number in front of my x squared. So this is log 11 x squared. Done. There we go. Okay. Let's take a look at another example. All right. We're going to have 6, that's a 6, natural log of x minus 4 natural log y. All right. So, again, what do you guys see here? Okay, we see these numbers in front mean we have power to a power. Power to power. So that 6 is going to go up here in the exponent. This 4 is also a power to power rule. So this 4 is going to go in the exponent for the y, and then this minus sign right here is the quotient rule. So when we put this all together, we're going to have just one log, natural log, and then we're going to have x to the 6th, quotient means division, x to the 6th over y to the 4th. And that's that. So when we condense, our goal is to write our expression with only one log. We don't want to write it with multiple, we only want it with one. We're condensing it and putting it all together into one. Alright, take a look at 2 more examples and you guys should be set. Alright, so example 3, let's say we've got 5 log 4 x plus 7 log 4 2 plus 4 log 4 of y. Alright, this one's a little bit of a longer one, right? Okay, so let's take a look at this. If it helps, take it one little step at a time. So, what I'm going to do is I'm just going to focus on condensing each separate log first and then work on putting all my logs together. So, this 5 is going to be moved back up to the exponent. So we're going to have log base 4 x to the 5th. This 7 is going to be moved back up to the exponent. So this is going to be log base 4 of 2 to the 7th. And this 4 is going to be put back up in the exponent. So this is going to be log base 4 of y to the 4th. Now what I want you guys to see here, so we have our plus signs in between, is this 2 to the 7th, that's an actual number, that's an actual calculation that we can do. What is 2 to the 7th? If I plug this into my calculator, 2 to the 7th power is going to give me 128. So, I'm going to write that here. This is log base 4 x to the 5th plus log base 4 of 128 plus log base 4 of y to the 4th. Alright, now to put this all together, remember these plus signs means multiplication. Right? So, I'm going to have just 1 log base 4. The reason we can put all these together is because the bases are the same. Alright, and we're going to have x to the 5th times 128 times y to the 4th. And just to rewrite that, because if we were to multiply these together, we would rewrite it to look like this. Log base 4, 128 would come first, then we'd have x to the 5th, y to the 4th. Alright, maybe do one other example. Let's say we've got the natural log of 40 plus 2 natural log of 1/2 plus natural log of x. Alright, to condense this, again, if it helps, do it one piece at a time. Now, if we take a look at this, natural log of 40, there's nothing that we can do to simplify that. So I'm just going to leave it as natural log of 40 right now. I can move this 2. So we're going to have the natural log of 1/2 squared, and that 1/2, that squared is going to the whole 1/2, not just to the 1 or not just to the 2, but to the whole thing. So that's why I put parentheses around it, and then we've got plus natural log of x. This is actual math. What is 1/2 squared? Well, you could plug it into your calculator, or we can do it in our head here. We're going to have natural log of 40 plus natural log of 1 squared is 1, and 2 squared is 4. So that 1/2 really becomes 1/4. The decimal you would have gotten on your calculator would have been 0.25, which is 1/4. Then we're going to have plus natural log of x. Now when we put this together, addition means we're multiplying. So we're going to have the natural log of 40 times 1/4 times x. Alright, there's some math that we can do here. 40 times 1/4. So I'm going to say is 40 over 4, and then we have that times x. And 40 divided by 4 is really 10. So this becomes the natural log of 10x. Bada bing, bada boom. Alright, there you go, guys. Let me know if you have any questions. See you next time.